Okay. After alkanes and alkenes, we take the nomenclature of alkynes, as alkynes has got a triple bond in it, at least one triple bond in the carbon chain. So the IUPAC nomenclature of alkynes is also similar to that of alkenes. So here what we have to do is we have to choose the longest continuous chain which includes the triple bond. That is selected as the parent. And in order to name the parent, we take the name of the alkane, cut off the E at the end of it and add YNE. So YNE instead of ANE. Alkane ends with ANE, alkene ends with ENE, and alkyne ends with YNE, alkyne. Then we number the chain. So the chain is numbered again in the same way like alkenes. We have to number it in such a way that the triple bond gets the lowest possible number. And that is written as a prefix to the YNE. For example, if the triple bond is at position 1, we will write the name as the name of the alkane, remove the E, put the number or the prefix of the position of the triple bond and then the term YNE. So we will see how that is done. And then after that is numbered, so the other branches, if there are other branches, they will get the numbers which automatically comes. And then those numbers are also written as prefixes in alphabetical order together with the position numbers of the different branches. And now if there is more than one triple bond, the positions of all the triple bonds have to be given as prefix when you name it. And in that case, you have to say, for example, if there are two triple bonds, you have to put diene. And if there are three, it will be triene and so on. So there will be the prefix number as well as the term di, tri, etc. depending upon how many triple bonds are there. For example, let us try to name these examples and then you will understand better. So here, this is the first example where you have a carbon here, a carbon here. So you can see that when you draw an alkyne, then the carbon after this triple bonded carbon should be in a straight line because this is the bond angle is 180. So it is not so correct to draw it like this. It is more correct to draw it in this way. This is better. So this is a carbon, this is a carbon, this is another carbon. So here 1, 2, 3, 4, 5 and 6. So the longest continuous chain containing the triple bond, in this case it is easy, it is 6. So the alkane would be hexane, the alkane would be hexane, but here because it is YNE, we remove the E and then add YNE. But we also have to include the position number. So the chain has to be numbered in such a way that it gets the smallest possible number for the triple bond, that is 1. Okay, so this is 1, 2, 3, 4, 5 and 6. So this is 1-ine. So the complete name will be hex 1-ine. Hex 1-ine. Now the next one here is also similar, but we have to be careful when we choose the longest continuous chain. That is the important thing here. So we have different possibilities for chain. The first possibility is like this: 1, 2, 3, 4, 5, 6 and 7. And another possibility is like this: 1, 2, 3, 4, 5, 6 and 7. We have to choose the red chain because that is the one which includes the triple bond. Even though the other one has got 7 carbons, that cannot be chosen as the longest chain because the triple bond is not in that chain. There is also one other possibility to get a third chain. We will see whether that is better. So here, this could also be a chain: 1, 2, 3, 4, 5 and 6. It has the triple bond in it, but the number of carbon is 6. Therefore, the correct one is the red one, the red chain, okay, where the red numbers are given. Now, but of course, that chain, that chain has to be numbered in 2 ways to find out which is the correct numbering. So this is not the longest chain because it does not have the triple bond in it. Then this is not the longest chain because it is only 6 carbon long. So 1, 2, 3, 4, 6, 7. Okay, and so this is the correct chain which we have, which is the longest continuous chain which contains the triple bond. Now there are two ways of numbering it, of course. You can number it this way. So this is 2, this is 3, 4, 5, 6 and 7. And the green numbering is better because that gives a smaller number to the triple bond. So this is hept 1 ine. So the name of the alkane was heptane, the longest chain. We removed the E and added Y and E, but we have to put the prefix 1 for the Y and E because the position of the triple bond is position 1. Now so you have understood how to choose the longest chain now. Sometimes it may not be the horizontal one, it may be one of the bent chains. It's not always that you have to choose the one which is written horizontally. No, you have to count the number of carbons and see which one actually is the longest chain. Okay. So next, we can look at the next example there where you have number of chains possible. Okay. So here 1, 2, 3, 4, 5, 6, 7. That's one possibility, which is the same as 1, 2, 3, 4, 5, 6, 7 or 1, 2, 3, 4, 5, 6, 7. All these are 7 and they are all identical also. So that means that you could choose any of them as the longest chain, but we have to look at the positions of the triple bond. The triple bond has to be included and we have to see the position to get the numbering correct. There is also one more possibility for chain, that is this one. 1, 2, 3, 4, 5 and 6. But that is, or here also it can be 6. But that is not the longest chain because it's only 6 carbon long. So we have to go for any one of the black chains. So let us choose one which is convenient. So this is not needed. This is not our longest chain. So we will just choose a convenient one because all of them are identical. Okay, so all of them are having 7. So I'm just going to choose the horizontal one as the correct longest chain. Now we can number it in two different ways. One already shown there in the black. Then the second one in the red, I can number like this, 2, so this is the 7. So 1, 2, 3, 4, 5, 6 and 7, which is the better numbering. So if we choose the black numbering, there are 3 methyl substituents and the triple bond is getting the number 4 if we choose the black numbering. Whereas if we choose the red numbering, the triple bond will be getting the number 3. So as you know, we have to choose the numbering in such a way that the triple bond gets the lowest possible number. So this is going to be the red numbering, and as a result, the methyl groups, the 3 methyl groups will be automatically at positions 2, 5 and 6. So we have to write 2, 5, 6 trimethyl, which we already saw. This method we already saw in the case of alkenes and alkanes. Trimethyl, and then it's a hept, so it is hept. And the position is 3 for the YNE and then YNE. So this will be the complete name of this compound. Okay. Next, let us see this case where there is more than one triple bond in the ring, in the compound. So here again we have to choose the longest chain in such a way that both the triple bonds are included. So here we can have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So that is a long chain. But if we go for, let us say, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, it is only 9 carbons, so we don't choose that as the longest one. We can start from here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, not good. But if we go 8, 9, 10, it's the same as the black numbering. So we could either choose like this numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or starting from here. It doesn't matter. Okay, both are same. I can start from here. I can just start from here or from here. It's the same. But we have to go to here, 10. And then let us look at the numbering. So we have to give the smallest possible number to both the triple bonds. So if I go from left to right, this is position 3 and then 4, 5, 6. So the positions of the triple bond will be 3 and 6 if I go from left to right. So positions will be 3 and 6 from left to right. But if I go from right to left, the positions will be, let me put the color red for that numbering, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So if I choose this numbering, the positions of the double bond from right to left, it will be 4 and 5, 6, 7. So of course this is better. This is better. That is, the black numbering is better. So what will be the name? So it is a decane with triple bond at position 3 and 6. So I will put dec 3, 6 diene because there are two triple bonds. So dec 3, 6 diene. But that's not all. There are two branches, that is two methyl groups. Look, this and this, they are methyl groups, and because the numbering we have chosen is the black numbering, the positions of the methyl groups will be 2 and 8. So I have to put 2, 8 dimethyl dec 3, 6 diene. That will be the complete name of this compound. So this is the case where we have more than one triple bond. Okay.